newest weapon haunting the streets of southern Ukraine is being printed by the thousand. They're plastic mines the size of your thumb and delivered by a Russian quadcopter. The shell of these weapons can be printed in under 20 minutes on a hobby-grade 3D printer. It's wrapped around camouflage fabric that makes the device vanish into the grass. Ukrainian police in Kherson flagged the devices in February 2026. Vladimir Pelopelitsa, head of the region's explosive ordnance disposal unit, explained that Russian forces had modified their older Prionic anti-personnel mines, printing new casings on hobbyist 3D printers and slipping in a detonator, an explosive charge, and the components needed for activation. The trigger is electrical, which makes it more sensitive than a mechanical fuse. The mines have no self-destruct mechanism. Why is Russia suddenly 3D printing mines? Because it's running out of the real ones. Officials say the new model may reflect dwindling supplies of Russia's standard PFM-1 butterfly mines, which have been scattered across Kherson by modified DJI Mavic drones since 2022. So the Kremlin's bomb makers adapted. They started printing. Human Rights Watch documented how Russian forces have modified commercial quadcopter drones to scatter anti-personnel mines in and around Kherson. In Antonivka, a resident told HRW investigators that the deminers had stopped answering calls. The work had become too dangerous. He and a neighbor began destroying the mines themselves, prodding each one with a long stick and then firing a rifle round to set it off. An entire city scans the dirt on the way to the market. These devices have already injured hundreds and taken dozens of lives. Now more than ever, a countermeasure for Russia's small, cheap, and omnipresent drone-deployed mines is needed, and Ukraine is using AI-assisted drones to trump the drone mine issue. In a field north of Kyiv, a drone lifts off at 80 meters. Its payload is a high-resolution camera feeding images to an AI model trained on real battlefield imagery. Software built by SafePro AI, running on AWS hypercompute infrastructure, processes each image in less than 0.2 seconds. The platform is now deployed by several humanitarian nonprofits in Ukraine, including Norwegian People's Aid and the Halo Trust, the world's largest nonprofit dedicated to clearing explosives left behind after wars. Field demonstrations have shown roughly 90% detection accuracy on surface explosives. A Ukrainian hackathon team called MineWatch AI recently won funding from the UN Development Program and the government of Luxembourg for a new detection model trained on roughly 30,000 real field images from Halo Trust and UA damage operations. So the race is on. AI anti-mine drones against mine-laying drones. On one side, you have cheap plastic charges printed in basements, scattered by modified commercial drones, hidden in fabric that eats the light. On the other hand, machine learning models run on cloud infrastructure, mapping minefields from the sky in milliseconds. Ukraine has about 67,000 square miles of suspected mine contamination, an area roughly the size of Florida, and at current resources, traditional clearance could take more than 750 years. Officials warn the number of landmine victims could reach 9,000 by 2030 if the problem isn't addressed promptly. A new American warship is coming, and it's designed to slide up into a Pacific beach and dump hundreds of Marines and up to 800 tons of missiles and military cargo on the sand. The Marine Corps recently dropped a video on social media showcasing their new medium landing ship, LSM. It's a pretty clever design, built to ferry troops and gear straight to the shoreline so they don't have to rely on big, vulnerable ports. In the video, a digital model of the ship pulls up to a beach, drops its front ramp, and rolls armored vehicles and Marines directly onto the sand. By removing the need for cranes or harbors, the ship eliminates logistical vulnerabilities an enemy might target. The cranes that work the birds take months to build and weeks to replace after a missile strike. Deep draft ships need specific beaches, approaches, and depths, all of them mapped. An offload runs for days. And for those days, the operation is stationary inside the enemy's reach. Known as the McClung class, the ship represents a major shift in how the Marine Corps handles amphibious operations, the biggest change since the arrival of the helicopter. For 80 years, American amphibious doctrine has revolved around the big deck. WASP, San Antonio, America, floating cities stuffed with helicopters, landing craft, and thousands of Marines projecting power from over the horizon. In a war with China over Taiwan, those big decks are targets. Anti-ship ballistic missiles like the DF-21D and DF-26 can reach out 1,000 miles. One lucky hit on a WASP-class vessel, and the Corps loses 2,000 Marines and a multi-billion-dollar hull in a single afternoon. The Navy doesn't like those numbers. Under a new operational concept called Expeditionary Advanced Base Operations, small mobile teams of Marines are meant to scatter across potential conflict zones in the Western Pacific. They carry anti-ship missiles. They move constantly. They vanish into islands the Chinese Navy cannot cover. To make the concept work, the Marines need small ships, cheap ships, hulls that can run without a port and disappear between kelp beds and reef lines. The LSM is that ship. The Navy's first attempt produced bids that were simply unaffordable for this high-end version. After that cancellation, the service settled on the LST-100 as a proven in-service design. Naval Sea Systems Command paid Damon $3.3 million for the technical data package and restarted the program around rapid production. The plan now calls for up to 35 ships, with 9 operational LSMs for each of 3 envisioned Marine littoral regiments, plus 8 additional hulls to account for maintenance. The new LSM is based on Damon Shipyard Group's Landing Ship Transport 100 design, which has a range of 3,400 nautical miles and can beach itself to deliver over 800 tons of cargo. The ship measures roughly 100 meters and is equipped with a flight deck capable of supporting unmanned aerial system operations. It can embark 250 Marines. A single LST-100 hull, the NNS Kata, was delivered to the Nigerian Navy in 2021, and Australia has selected the same design for an 8-ship landing craft heavy program. Wisconsin shipbuilder Fincantieri Marinette Marine was awarded a $30 million contract for long lead material and planning for 4 planned McClung-class medium landing ships, with construction expected to start late this year and the first delivery targeted for 2029. The lead ship will be named USS McClung, LSM-1. The class honors Marine Corps Major Megan M.L. LeClung, a U.S. Naval Academy graduate and public affairs officer who fell in 2006 in Iraq, alongside Captain Travis Patriquin and Specialist Vincent Pomonte III to an improvised explosive device in Ramadi. She was the first female Marine officer to perish in the Iraq War, and the first female graduate of the Naval Academy to lose her life in the line of duty. Now, her name leads a class of warships built for the opposite problem Iraq posed, a peer war across the Pacific. The Pentagon strapped a classified weapon to a commercial rocket and fired it into the sky at more than 5 times the speed of sound. The launch occurred in the early hours of Wednesday, April 22nd, from Launch Complex 2 on Wallops Island, Virginia. The mission was codenamed Bubbles. It went up at midnight. It came down somewhere over the Atlantic an hour later. The details of the payload were not disclosed, not the customer, cargo, or outcome. The only thing anyone will confirm is that whatever rode up that night was hypersonic, experimental, and headed downrange faster than Mach 5. That company in charge was Rocket Lab. The program is HASTE, short for Hypersonic Accelerator Suborbital Test Electron, and it's eating the bureaucracy alive. HASTE is built on Rocket Lab's flagship Electron rocket. Engineers strip out the parts needed to reach orbit, keep the workhorse first-stage engines, then repurpose the rest to scream through the upper atmosphere at speeds faster than Mach 5. The modifications let HASTE carry up to 700 kilograms while flying custom trajectories suited for aerodynamic testing, with larger fairings available when a payload demands extra room. Each HASTE launch is priced around $6 million. In the world of strategic weapons testing, that's pocket change. The implications are enormous. Speeds above Mach 5, compressed decision timelines for defenders while complicating tracking and targeting. They glide, they maneuver, they punch through missile defense at altitudes and velocities where radar struggles to hold a lock. For years, the United States lagged behind China and Russia on hypersonic weapons. Moscow fielded the Avangard. Beijing paraded the DF-17. Washington kept burning through billions on programs that slipped years behind schedule. So the Pentagon did something the Pentagon rarely does. It got out of its own way. The Department of Defense stopped waiting for traditional test ranges and bespoke government vehicles. It went to a commercial launch company and started buying rides by the trip. The Bubbles mission is just the latest chapter in a rapidly accelerating story. Just 2 months ago, on February 27th, Rocket Lab sent up Cassowary Vex, a hypersonic testbed for the Defense Innovation Unit. Earlier tests involved the DART AE, a sleek 10-foot vehicle powered by a 3D-printed scramjet engine, designed to push the boundaries of high-speed maneuvering. Rocket Lab secured a $190 million deal in March to keep these missions flying for the next 4 years. HASTE has now become the backbone of the military's Advanced Hypersonic Testing Program. Through it, the Air Force has ensured the testing pace won't slow down anytime soon. Rocket Lab founder Peter Beck called it, quote, operational speed and cadence. Each of these launches allows the Pentagon to learn from failures and refine its tech in weeks rather than years. Rocket Lab has 3 more HASTE missions scheduled for the coming months. Every flight the United States runs on HASTE teaches engineers how to build the countermeasure, how to harden the glide body, and how to tune the scramjet. Every flight China and Russia are forced to watch is a flight that narrows the gap. The Army just landed a 25-ton Chinook without pilot input. The aircraft touched down with all 4 wheels on the runway without any pilot interaction, using the new digital automated flight control system software. Boeing announced the milestone on April 16th, declaring it the first time that a U.S. Army CH-47F Chinook had completed its first fully automated approach and landing during a flight test of its approach to X, or A2X technology. Landing is often the most dangerous part of a mission. Between the blinding brownout dust clouds kicked up by the rotors and the sheer mental exhaustion of the final 60 seconds, where you're fighting the wind, watching for threats, and trying to set a 25-ton machine down on uneven dirt, it's the moment where most crews are at their limit. Automated approach systems free the pilot's attention from the landing process and direct it to threat detection during one of the most vulnerable moments of the Chinook. Though the U.S. military is developing countless unmanned projects, few carry the responsibility of protecting human lives and vital cargo. The program that seeks to address this is called A2X. It runs inside the Chinook's upgraded flight control system. Pilots choose a landing zone and final altitude, either in the air or on the ground, then set an approach angle and a start speed. The software guides the aircraft to that point and handles the control inputs needed to get it there. Pilot inputs can still adjust the final course and glide slope in response to a changing tactical environment. Deanna DiBernardi, H-47 Human Factors Engineering Lead at Boeing, said, quote, "We built the interface and control laws around how pilots would naturally fly an approach. Our goal is to reduce pilot workload so crews can maintain more eyes-out awareness in a tactical situation." Since its first flight on a U.S. Army CH-47F in January 2026, A2X has been steadily working toward the monumental milestone of a fully autonomous landing. It completed over 150 approaches, with final altitudes ranging from a 100-foot hover to the ground, with an average final position error of less than 5 feet. On a 98-foot aircraft with counter-rotating rotor discs spanning 60 feet each, at the exact moment when human pilots are juggling a dozen separate inputs, the software was putting it down in a parking space. The Chinook milestone did not happen in isolation. On March 19, 2026, the U.S. Army took delivery of the H-60MX Blackhawk optionally piloted vehicle at Fort Eustis, Virginia, more than a year after DARPA contracted Sikorsky to equip the experimental fly-by-wire Blackhawk with Matrix, the company's flight autonomy software. The aircraft, owned and operated by the Army, is the first full authority fly-by-wire and optionally piloted UH-60 in the service's fleet. At the same time, the Army is beginning to reshape the human side of aviation to match this new reality. Plans are already in motion to cut more than 6,000 positions tied to crews and pilots. A quiet but unmistakable signal that autonomy is no longer a supporting feature. It's becoming the foundation of a new age in aviation. The thinking behind this is straightforward. In a major conflict, the Chinooks and Blackhawks moving fuel, ammo, and the wounded through dangerous skies are vulnerable. They're big, slow, and easy to predict. Anti-aircraft solutions are getting cheaper and more accurate by the day. Boeing says the next phase of A2X testing is already underway.